In today's video, I will talk about quadratic equation and completing the square. So quadratic equation is, in general form, is ax squared plus bx plus c equal to 0. In grade 10, we have already learned factorization, and factorization is very useful when solving quadratic equation. So for example, this one, we can first factor out 2 and divide 2 on both sides. Then this one, we have already learned how to factor it. We factor it into x minus 3 and x plus 2 equal to 0. So we have two solutions, x equal to 3 or x equal to negative 2. Another example is when the parameter in front of x squared is not 1. So this one could be a little bit difficult. So let's take a look. So we still do factorization. So first, we know 2x squared, if we factor it, it's going to be 2x plus something times x plus something, right? So my habit is to write it into vertically to help me easier to think about it. So you can use this one as well. So we know that it's going to be 2x and x, and these two numbers times together is negative 5, and 2x times this plus x times this going to be negative 9. So we will have 5 and 1. Then 2 times 5 is 10. 10 minus 1 is 9. So in order to get negative 9, we have to negative 10 plus 1, right? So finally, we figured out it's 2x plus 1 times x minus 5. This is our factorization. So we have two solutions, x equal to negative 1 over 2, or here x equal to 5. So sometimes if we cannot factor a quadratic equation, we can use the method that is completing the square, or simply we use the quadratic formula. So let's first see completing the square. It's the process of rewriting the general form ax squared plus bxc plus bx plus c into the vertex form a times x minus p squared plus q. So take this one for example. We first divide 2 on both sides, we get this. This one seems not factorable, so we have to use completing the square. So first, it said isolate the variable terms on the left side. That means we move the constant part to the right hand side. We have this. And the next, completing the square. That is, we have to add a number here to make the x term into a perfect square. So we know we plus 1 here, and we plus 1 on both sides to make it equal. Then the left hand side become a perfect square. The right hand side 1 plus 1 is equal to 2. Then we can square root on both sides, so it becomes x minus 1 equal to positive or negative square root of 2, right? So now we have x minus 1 equal to square root of 2 or negative square root of 2. So we move 1 to the other side, we get x equal to 1 plus root 2 or 1 minus root 2, two solutions. So completing square is something need practice. So let's do some practice here. First, we have to add a number to make this one a perfect square. So we know that x minus 3 squared is x squared minus 6x plus 9. So here we have to add a 9 to make the perfect square. The second one, we know that x plus 5 squared is x squared plus 10x plus 25. So we plus a 25 here. And in general, we can see 9 is equal to 6 over 2 square, and the 25 is 10 over 2 square. So if in general, if it's b here, we have to add a b over 2 square. If the parameter in front of x squared is not 1, so we have to first factor out the parameter. So in this case, we factor out 2, then we're completing square of this. So we know for this one, completing square, we have to add 3 over 2 square, and it becomes 2 still outside, and the inside becomes x plus 3 over 2 square. And lastly, in the general form, ax squared plus bx, we first factor out a, and it becomes this. So we know we have to add b over 2a squared. So it becomes ax plus b over 2a squared. Let's see one more example here. So in this one, we divide -2 on both sides. It becomes this. This one we cannot factor, so we completing the square. First, move the constant to the right-hand side. And for this one, we know we have to add a 3 over 4 square. So 3 over 4 square is 9 over 16. So we add 9 over 16 on both sides because it's an equation, right? We have to add a number on both sides. So after that, the left-hand side becomes a perfect square. The right-hand side, after calculating, becomes 65 over 16. So now we can square root on both sides. We have x plus 3 over 4 equal to positive or negative square root of this. Finally, we move 3 over 2 to the other side. We got x equal to this. So in many cases, as you can see in the previous case, for example, completing the square can be long or difficult. The good thing about math is mathematicians already denoted a lot of formulas, equations that we can use. It's very handy. So we can simply use a quadratic formula. That is, in this general form, x is equal to -b plus or minus square root of b squared minus 4ac over 2a. This is a quadratic formula, can be very handy. I recommend you memorize this. If not, sometimes the formula will be given. This is a proof how we denote the quadratic formula. Let's take a look. So if this is a quadratic equation, we first divide by a on both sides. It becomes like this. And then we move the constant part to the right hand side. The next step, in order to make the perfect square, we have to add b over 2a on both sides, right? So then the left hand side becomes a perfect square. The right hand side, after rearrange, becomes this. Then we can just square root on both sides and move b over 2a to the other side. So we get the quadratic formula. It's actually not that bad. So let's take a look at one example. Let's take a look at the previous example. Remember this one? We used completing square to solve. This time we use the quadratic formula. We just plug in -b, so -3 is +3, plus or minus 3 squared minus 4ac divided by 2a, right? So yeah, it gives us the same solution. So now you can see the quadratic formula is very handy and much easier to use than completing the square. So finally, in the quadratic formula, the quantity b squared minus 4ac under the square root sign is called the discriminant. The symbol delta is used to represent the discriminant, delta equal to b squared minus 4ac. So the quadratic formula becomes negative b positive or negative square root of delta minus 2a, where delta is b squared minus 4ac. There's one important rule that you should know. So when delta equal to 0, square root of delta is a positive real number. So there are two distinct real solutions, right? If delta equal to 0, x becomes negative b minus 2a. So there's only one solution. This is kind of a quadratic equation that finally can become like x plus a squared equal to 0. In this case, there's only one root, x minus negative a. If delta is smaller than 0, the square root of negative number is not a real number, so no real solution. This is kind of equation that we can finally change into x plus a squared equal to a negative number, for example, negative 1. In this case, a square number cannot be negative, so no solution. Okay, thanks for watching.